Okay, let's discuss bending operations. As you see on this sketch, we have some parameters regarding the bending operations. Obviously, we are using sheet metals, and these, with the help of dies and some die set, punch, we try to bend this flat sheet metal into some degree, into some, let's say, special shapes. And obviously, we have bend angle, this is alpha, and we have bend radius. And later we will see that this radius changes after the punch or after the force is removed from this sheet metal. Since we have recovery, elastic recovery, due to that, the actually sheet metal tries to go back to its original shape, and we have about 3 to 5 degrees of usually spring back, and we need to find some ways to overcome this problem. And why bending is important, since if you simply bend some corners, some edges, then you are going to increase the moment of inertia, and that will result in an increase in stiffness. So this is highly important. For instance, if you are just using a sheet of paper and wanna hold something on it, then you cannot do that due to the less strength of this paper. But if you bend it from the edges, you may increase the strength and at least try to hold some lightweight products. And in this bending operations, after this bending, actually we have the tensile stresses on the outer surface of this band, and we have compressive stresses inside this band. And usually we try to actually make use of some sheet metals which are rolled in this direction. And I think we have an example for that. Yep. You see, if this is actually manufactured in this direction, we are assuming that these two parts are manufactured with rolling. And in this first one, rolling direction was this to the right. And in this one, it's actually along the length of our sheet metal. So if you do the bending in that direction, then you will have no cracks on the outer boundary, but you will have tears, cracks if you actually do the bending in the opposite direction. And we have some equations regarding the math behind this bending, but you're not responsible from that. Let me briefly talk about once again spring back. I said that we have some elastic recovery after this bending operation is over. Once you remove the punch from your sheet metal, our metal will actually try to go back to its original shape, and due to that, we will have a larger radius as opposed to the radius of just after the bending. You see, this is Ri initial radius and Rf final radius, and this is the amount of spring back. This is initial bend angle and final bend angle. And as I said while we were watching the video, there are different ways to overcome this spring back phenomena, spring back problem. The easiest one is actually overbending the part. And most people, most companies are doing that. How they find this amount of overbending? They perform many experiments and then check the angle and try to find this extra bending for each type of material. Since if you change from, let's say, from aluminum to steel, then all your parameters will be different. So for each material, you need to be performing these experiments once again. Or we may be using bottoming. This is actually applying more force on the, and we will be squeezing our sheet metal in between the punch and the die. And if you apply more force, then the amount of spring back actually decreases. We will have some, but at least it will be decreased. And there are, as you see, different types of, more types of spring back elimination. You may use again a kind of a rocker, as we have seen again in the video. But the easiest way is actually overbending the part. Since in all other cases, you will have some amount of spring back. It's obviously less, but you will still have. So if you don't wanna deal with such an spring back, you should be finding this overbending value and try to overbend your part so that once it recovers actually, you will obtain the desired angle. And we have different types of bending operations. This is called as air bending or 3-point bending, as you see, 1, 2, 3. With the help of the sponge, this part is bended. Or we may be using a force light machine, especially if you are producing kind of circular shapes. You cannot do it with a single punch. It's better you make use of some side, let's say, punches and an upper punch. So if you do it, you can obtain, as you see, some circular shapes out of your flat sheet metal. Then we have roll bending. This is a nice and simple way of bending actually sheet metals. We have one of these machines in our machine shop. What we do, we simply adjust the height of this actually roller, and then feed our sheet metal in between, and then it will actually be bended, as you see, into a kind of an arc. You cannot have 90 degrees or some specific degrees, but the resulting sheet metal will be a kind of an arc. And this radius, the radius of this arc is set by this roller. So I've seen that these bending operations are mostly done on press brakes. We may have mechanical ones. There are mostly hydraulic ones in the industry. And you'll see what we are using in these press brakes. We have such special dies, and these are mounted here. And then on the top, we have the ram, and at the tip of the ram, we have such punches. And what we do is simply feed our sheet metal in between, and then press brakes goes downwards and shapes our sheet metal. You see there are different types of die sets, channel forming, joggle, and you have less elevation difference, or hemming, flattening the edges, as you see, or if you have some kind of an offset, you may even try to lock two sheet metals together. So depending on your application, on your aims, you may find the proper set of dies and then try to use the same press brake. And I discussed about bending in a force light machine. This was it, by the way. And then we have roll bending. I discussed it. And then we have beading. This is a bit special thing, a special bending process. We are trying to actually bend our sheet metal into the cavity. There are some examples you see. This is our die. We push our die over the sheet metal, and due to these forces, sheet metal is bended actually around the perimeter of this die. There are different ways, but the idea is that. Then we have flanging. This is about bending the edges of sheet metals, usually to 90 degrees. And since these edges are quite actually sharp and they may be harmful to the users, so what they do, they simply bend these edges. And for that purpose, they have special dies and punches, but the rest is not difficult. And then we have roll forming. Actually, this one is a kind of a rolling operation. If you remember, we discussed the rolling operations in chapter 13, as far as I remember. This is somehow in between bending and rolling. So that's why they call it as roll forming. So what do they have? They have many sets of rolls, but as you see, the shape of the rollers are quite different. We feed in sheet metal, obviously, at the beginning. And once these stages are completed, we can obtain such complicated profiles. Then we have tube bending and forming. Again, what we do, we have a die, we put our tubes, pipes into that die and try to bend it. But the difficulty in tube bending is that since the strength of the tubes are not high, we may have buckling, folding, wrinkles around your pipe tubes. So what we do, we usually fill the interior of these tubes with some loose particles, usually sand particles, and then with the help of it, we will not have much deformation. We will be eliminating buckling. And you can see some examples here. As I said, the interior of these pipes are usually filled with some sand particles, or maybe sometimes such balls or springs. It's up to you, up to the designer, and even you can have more complicated ones. Then we have bulging process. It's a bit different. This time we make use of actually a flexible kind of a rubber here. This is a mechanism for bulging operation. This is before the process, and this right hand side is after the process. If you look at here, this is our die. So we want our sheet metal to take the shape of this die after this bulging process. So what happens here? This is our punch. This punch moves into the die opening. Since inside this die we have rubber, and if you apply pressure on this rubber, it will be modified, and it will apply pressure on these side walls, and our sheet metal will be bended. And you'll see these are some example work pieces which can be manufactured with bulging operation. Then lastly, we have stretch forming operation. This is a very special process and mostly utilized for very large sheet metals, and it's done in obviously aerospace industry, since they have such larger panels. And I would like to show you an example. Yeah, this is it actually. Since this is called as we stretching the sheet metal and then do the bending operation. Since once you stretch, then with less forces you can shape these sheet metals. This is the main idea behind this stretch forming operation. But the thing is that it's quite difficult to stretch properly. If you apply too much force, then you may actually break. Some tears may happen, so you should be careful about it. And another thing is that you can only obtain smooth surfaces. You cannot have some angles, right angles. It's not possible. As you see, you have to design a smooth tool, and then with the help of this tool, you may bend it without an extra punch. This one is since rotating, but there are also different ways, like this one here. You may have a kind of a table. You prepare your die set and punch, you see, and stretch your sheet metal and apply these forces, squeeze your sheet metal in between, and try to have these shapes. And as I said, this is mostly utilized in aerospace industry for the manufacturing of larger such skin panels. Now let's continue with deep drawing. This is another main sheet metal operations. With the help of it, actually, we obtain some cup-like shapes. With drawing, this is the only shape you can obtain. And if you look your actually devices in your kitchen, most of them have such shapes, right? The pans, the cups, other kind of things, kitchen sinks. We also have some examples in automotive industry. The fuel tanks, they are usually in the shape of cups. The beverages, cans, they are all in the shape of such cups. And we can manufacture these with the help of deep drawing. The tools are somehow similar to shearing, but this time we are not cutting. What we do, as you see, we place again our blank material, blank sheet metal in between the die and the punch, but this time we don't have sharp corners and we have larger clearances. So our aim is not to cut, not to shear, but this time we will be bending and we will be actually pushing our sheet metal into this die. And with the help of these forces, special arrangement of the punch and the die, we will obtain a cup. As you see, this a drawn cup is obtained with the help of drawing, deep drawing operation. In order to actually hold this blank material in position, we need to again have blank holder. If you remember fine blanking operation, we were using some similar paths, and this time it's a must in deep drawing operation. Another issue is that we don't have sharp corners on the die and on the punch, since we don't want to have shearing, we don't want to have cutting operation on the sheet metal. You see, we simply push our punch into this die, and after this operation, it will take the shape of a cup. And later, with the help of this stripper ring, we can easily eliminate, we can easily remove our cup from the punch, since otherwise they may be to stick together. You cannot easily remove this cup from the punch. With the help of this little thing, the cup is actually removed in an automated manner. So what are the important parameters in this deep drawing operation? First of all, the length, the initial diameter of the blank is important. This is D0. And the diameter of the punch is obviously important. The radius of the punch, the corner radiuses, of the punch and the die, and obviously the thickness of the sheet metal is highly important, since these will all affect the amount of force we need to apply. If you apply actually less force, then you cannot do the bending operation. But if you apply too much force in a shorter time, then you may be cutting your sheet metal. So the force is highly important in this deep drawing operation. Let me go back to the fundamentals here and discuss these. Let me check. And as I said, we have many variables. The properties, mechanical properties of the sheet metal, the ratio of the blank diameter to the punch diameter, the clearance, the ready, the force we are applying, the friction obviously between different walls, and the lubrication if you are applying or not. And we know that if the die and the punch is actually properly lubricated, we can use them for a longer time. And here you can see a nice actually processes to obtain a kind of a beverage can. Let's have a look at them one by one. The first process is blanking, and with the help of this blanking process, what we obtain, this is a circular shape we obtain. And then later what we do deep drawing. This is the process right now we are discussing, and you can see that we have ready on the punch, but in the previous one we don't have that radius. And we try to do deep drawing, and you can see we have obtained a little cup shape, but the depth is not too much. So what we do, we perform redrawing operation. So this is actually, as the name implies, drawing, performing another drawing operation on the already drawn part. Our aim is to actually increase the depth of our cup so that it will be useful for us. And then later what we do, we use another deep drawing operation. This is called as ironing. And the main aim is to decrease the thickness of these walls. If you compare, for instance, in the previous processes, we have the same thickness for the walls, but this time with ironing, the thickness of the side walls are decreased, and obviously due to the constants of the volume, the depth of this shape is increased. And then later we do a kind of a bending and maybe forming operation. You see we have a special die here. So the bottom of this cup is actually deformed in the shape of a dome. Then we do necking, and this is done at the edges of the upper part. And this is a kind of a preparation stage for the last part. So in the last part, we are trying to close this can, and this is done with the help of an extra part and seaming operation. You see, this is our lid. The blue one is lid, and the gray one is our drawn cup, and we are trying to close it with the help of seaming. So we are seaming the edges, the periphery of this upper part, and with the help of it, without any welding operation, without any other joining operation, we can simply join two sheet metals together. And let me briefly discuss some other issues about deep drawing. And in deep drawing, the forces are highly important, as I said, in order to have, not to have any wrinkles, any tears, cracks on these actually sheet metal. People try to find some different ways. For instance, this is an example. They have such beads, and this bead is actually holding the sheet metal on this table so that it will be an deep drawing operation other than different operations. And if you want to avoid tearing, you should actually spend more time on the design of your beads, more time on the design of your die, so that the ready of the die and the punch will be fine enough. You should have proper lubrication. You should be checking the size of your blank material so that after the operation, it will have the desired size. And another thing, you shouldn't always have sharper corners. It's better you have at least 45 degrees at this corners, and that will be improving the quality of your actually resulting shape. And again, the burrs are highly important. If you should be checking your initial material so that there shouldn't be any burrs. If you start the process with the sheet metal having burrs, then you'll have difficulties. And I already discussed ironing. This is it actually. I already discussed redrawing, but we have a reverse drawing operation, a bit different than the redrawing we have seen in the manufacturing of the cans. You see what we do, we simply reverse the sheet metal and have a more complicated shape. These are still drawing operations, but this time in the second case, we change the, let's say we put it upside down and do the drawing operation once again. But in the conventional redrawing, we don't change the orientation. We may have some kind of a step shape, so we change the die to a smaller one and try to have such as stairs on the edges of our cup. Embossing, it's a very similar process, but the main difference is that this time the depth of the die is not too much. We have shallow dies, and our main aim is to actually embed some letters, numbers, some special shapes onto the sheet metal. You see, this is our die set, male and female dies. We put our sheet metal in between and then press, we apply forces, and this pattern will be embedded onto the top surface of, or the bottom surface of our sheet metal. Let's continue with rubber forming and hydroforming. Again, obviously we are using sheet metal in this process. And in the rubber forming, as the name implies, we will be using rubber to shape our sheet metal. And this is called sometimes as Guerin process or rubber forming. And in the hydroforming, we are using still a tin of rubber, but most of the manufacturing is done with the help of oil inside a tank. And let's have a look at the cases here. This is actually a rubber forming or Guerin process. You see that we have a punch here, and this time our female die is made of flexible material. This is mostly made of rubber. So what we do, we again move our punch into our female die. Since in between we have the sheet metal, obviously the sheet metal will be covering the surface of our punch. You see, it takes an L shape, and in this one it's a bit different, and we have such a shape here. And in the last one, it's more complicated. We have no actually features on the female die. It's a flat one, and as you see before the process, this is the case. But after you move the punch into the die, our sheet metal will take the shape of our punch. Then in the hydroforming process, what we have, we need to use some special tanks, and this tank is usually filled with oil. The pressure is obviously highly important here, and in between the oil and the sheet metal, we have a flexible material. This is rubber diaphragm, and again we need to have a punch. But what we do, we push our punch again onto the sheet metal, and our punch will be going into the tank. And as you know, the pressure is higher inside here, so that it will be applying some triaxial compressive stresses on the sheet metal. And again, our sheet metal will be covering the punch, as in the case of rubber forming operation. And we can also perform this process on tubes. The idea is the same, no difference. Again, if you apply pressure inside here, then the walls of this tube will be deformed, and it will take the shape of the die. You can see, for instance, here we have much more complicated tubes, pipes, and these are obtained with hydroforming process. So this is actually summarizing what happens in hydroforming. You see, initially we have such a pipe, and then once you increase the pressure of this fluid here, you have compressive stresses, and that will actually modify the walls of our tubes. Then we have spinning process. This is a bit different process than the other ones. As the name implies, we need to be just spinning our sheet metal. And with the help of this process, we can only obtain axisymmetric parts. You can see the fundamentals here. What we do, we again start with a circular blank material. We place it in between the mandrel and the clamp. And obviously, this mandrel is connected to a spindle, is moving at some speeds. And what we do later, you may do it manually by simply moving this tool over the surface. And then what will happen? Our blank material will take the shape of our mandrel. So we will be covering the mandrel with our sheet metal. You can see some types actually which are obtained by spinning process, and they are all axis symmetric. And instead of doing it manually, you may even use some CNC type of equipment. But if for the complicated shapes, for simple shapes, if you are an experienced worker on spinning, then you may do it yourself. Another issue you can see is that we are using a kind of a roller. Since we don't want to have cutting operation, we don't want to remove material from the surface, so that's why we are not using sharper edges. Instead, we use such a roller so that without removing material, the blank material can be spun. And we have some types of spinning processes. The first one is shear spinning process. You see our aim is actually decrease the thickness of this initial sheet metal and have a kind of a cup shape. And another thing is that the diameter is the same. As you see, this is the initial diameter, and once the process is completed, again, our cone will have the same outer diameter, but the difference is that it has a less thickness, and this is called as shear spinning. Then we have tube spinning operations. We can perform it on the outer surface or on the internal surface, it doesn't matter. The idea is the same again. Our sheet metal is skewed in between mandrel and this stop here, this holder or clamp, and then by using our tool, feeding our tool in this case from right to left, we try to decrease thickness and try to increase the depth of this cup shape. These are the things I discussed. Then we have incremental forming. It's a bit different. We use such a longer kind of a stick, and again, move it over the shape in a kind of a helical manner and try to obtain such shapes. I think we are almost done. We have some other special processes. This one is called as explosive forming, and as the name implies, in order to shape, in order to modify our sheet metal, we are making use of explosives. And this is mostly done on larger sheet metals again. And since we will have some fires, explosives, explosions, that's why we mostly do it inside water. We place our explosive in water, and then we need to actually put our die and kind of set into this water tank. And another important thing is that you see we have a vacuum line. We need to actually suck out of this air from this die. Otherwise, once you have explosion, the forces may not be enough to bend this shape. Since if you do vacuuming here, then what will happen? We will have no air here, so the pressure is lower. So once you do the explosion, you can easily shape this sheet metal. Then we have electromagnetic acid forming. The idea is again the same. The only difference is that instead of explosives, we are using magnetic forces. You'll see this is an electromagnetic force. With the help of it, again, our sheet metal is bended or shaped. Then we have pin forming. And in pin forming, we make use of shot pinning operation. We have little particles, and these are shot onto the workpiece. And with the help of them, we obtain some curvatures on the flat surface. And we can do it on very longer shapes. So again, this may be highly useful for aerospace industry. With the help of these compressive stresses due to the shots, we obtain much better properties on the surfaces. Then we have laser beam forming. The idea is not difficult. We simply increase the temperature of some specific regions with the help of laser beam, and then apply some force and try to shape them. Since once you increase the temperature at that zone, let's say, then the strength of the part will be decreased, and with less force we can do the forming operation. And if you do all these operations in micro levels, then it's simply called as microforming. Then we have actually extrahydraulic forming. This time, instead of using explosives, what we do, we make use of sparks. As in the case of EDM process, again, with the help of them, we shape the sheet metals. And this is actually all for the processes. Let me talk about equipment we can use in these processes for these processes. As we have seen in the video, we mostly use actually press brakes to manufacturers to actually perform these manufacturing operations on the sheet metals. We can have hydraulic ones, mechanic ones, pneumatic ones. So depending on your required force or required speed, you can go with any of them. And if you look at the shapes of them, there are some differences. The most popular one is C-frame design. The advantage is that you can have highly longer workpieces since this part is open. You can easily feed your sheet metal into that opening. But the problem is that if you apply too much force, then there might be some deformations on your machine. Since it's a C-frame, so if you apply force here, then there will be bending on the machine, and that might be a big problem for you for high quality operations. Then we have other designs, white design, adjustable bed so that you can move it upwards, open back inclinable. You may have some angles here. And the last two ones are useful for thicker metals, thicker sheet metals, since they are quite stable compared to C-frame. You may apply higher forces and there will be no deformation on the machine. But the thing is that you can only economize smaller sheet metal. You cannot have longer sheet metal since the side surfaces are closed, as you see here. You can only have smaller sheet metals. Let's briefly look at the economics behind deep drawing. And it's a very useful process, but you should be careful about the number of products you're going to manufacture. If it's low, then obviously you shouldn't be going with deep drawing, but if the number is high, then you may use deep drawing since it's highly useful, as you see, for this shape, for instance. If the number is higher, it's much better than spinning, and it's also much better than casting and some other manufacturing operations.